to my YouTube channel Messages Corner. I am Mukul Sarma, teacher. Today I shall discuss about some problem which are in the exercise number 5.3. This problem is I have to solve 2x square plus x plus 1 is equal to 0. I have to solve it. This is the quadratic formula. Comparing with this with quadratic equation ax square bx plus c is equal to 0, we get a is equal to 2 here, coefficient of x square, and the coefficient of x is there is 1, and coefficient of and constant term is here 1, see, therefore x is equal to, it is a quadratic formula. We have got in class 10 level minus b plus minus b square minus 4ac 2a minus 1 plus minus I square minus 4 to 1 2 that y j. This is after simplification. We get 1 minus 8, and this is minus 1. We cannot get here real roots. Roots will be imaginary because this is b square minus 4 is less than 0 here. We have got this condition earlier. Therefore, we can write is root over minus 1 to minus 7, and root over minus 1 is I. Therefore, we can write this. So, roots are this. Our next problem is this is, we can see this is x square plus x plus 1 by root 2. If we multiply both sides by root 2, we get this formula as root 2x square root 2 plus 1. This is here also a is equal to root 2, b is equal to this is, and c is equal to 1. Quadratic formula this is, we can put this value here, root 2 square 2, 4 root 2, minus root 2 plus minus, we can take 2 common from here, 1 minus 2 root 2, that is minus root 2 plus minus, this is root 2 root over 1 minus 2 root 2. Therefore, this is a, if we take root 2 common from here, root 2 is equal to minus 1 plus minus, this is 1 minus 2 root 2. Now we just simplify it, minus 2 root 2, we cancel minus 1. We can 1 minus 2 root 2, we can write is root 2 minus 1 if we take minus in outside the bracket, because we know a minus b, we can write it as b minus a if there is minus outside the bracket. Therefore, this is minus 1 plus minus 2 root 2 minus a. This is minus symbol, means this is root over minus 1. We can do minus 1 plus this is I. This is by 2. This is the answer for this problem. Now I discuss some miscellaneous exercise in the chapter number 5. That is find the value of I to the power 18, 1 by I whole to the power 25, and a whole cube. Now solution. There is I to the power 18. This is just like this. Now we have to split. 18 in terms of 4. That is either 4, so that 4, 16. 4 into 4, 16. There is 18. There was 2 is there. I square. 16 plus 2, 18. In 1 by this 1 to the 1 by I to the power 25. This is I to the power 4 is equal to 1. And therefore, this term will be 1. This is 1. I square will remain. This is also, we have to split in terms of 4. That is I to the power 4. 6 into 4, that is 24. But there is 25, therefore 1 I is there. Whole cube. This is 1. This is 1, therefore 1 by I only. Next, the I square is equal to minus 1 plus 1 by I, which is minus I plus 1 after taking LCM. So therefore now we have to remove I from denominator. For this we have to multiply another I in the numerator and denominator. That is 1 into I, this is also A into I. This is I minus I square plus I, which is I square. Yeah. Minus I square is equal to 1. Since I square is equal to minus 1, therefore minus I square is equal to 1. This is I, 1 plus I. This is, we can write this as minus 1 plus I whole cube. And now we will just simplify with the help of cube formula. A plus B whole cube, such type. First A cube, B cube, thrice A square B, thrice AB square. Here A is 1 and B is I. 1 cube, 1, I cube minus I, 3, 1 square I, this is 3I, 3, 1 I square, this is I square, I square is minus 1, therefore minus 10. After simplification we get this. Next problem, that is for any complex number Z1, Z2, prove that a real part of Z1 into Z2 is equal to real part of Z1 into real part of Z2 minus imaginary part of Z1, imaginary part of Z2. Let the complex number, Z2 complex number, Z1 is equal to A plus IB and Z2 is equal to C plus IB. Now we have to multiply Z1 and Z2, Z1, Z2, A plus IB, C plus ID, AC, A into C, AC, A into ID, AID, IB into C, IBC, IB into ID, I square BD. Or AC plus, if we take common here, from here we take common, this is I square is minus 1, so minus BD. AC minus BD, AC minus BD, and this is A plus IB form, where this is the real part and this is the imaginary part. The real part of Z1 into Z2 is equal to AC minus BD. Again, from here, from RHS, a real part of Z1 into real part of Z2 minus imaginary part of Z1, imaginary part of Z2, that is SC. Real part of Z1, that is A. Real part of Z2, that is C, minus imaginary part of Z1, that is B, and imaginary part of Z2, this is D, that is AC minus B. From 1 and 2 we get this is equal this is, therefore this is also equal this is. Real part of Z1 into Z2 equal to real part of Z1, real part of Z2 minus imaginary part of Z1, imaginary part of Z2. Next is since 1 by 1 minus 4i, 2 by 1 plus I, bracket 3 minus 4i, 5 plus I, to standard form, that is it is A plus IB form. Now we have to simplify this first. Therefore, taking LCM 1 minus 4i 1 plus 4, this is 1 minus LCM 1 minus 4i 1 plus I, this is 1 into 1 plus I, 1 into 1 plus I, 2 into 1 minus 4i, 1 plus I, there 2 into 1, 2 into 1 2, minus 2 into minus 4i, this is 8i. 1 minus 4i, 1 into 1, 1 into I, minus 4i into 1, minus 4i, minus 4i into I, minus 4i square. Therefore it is 1 minus 2, that is minus 1. I plus 8i, that is 9i. This is 1, this is I minus 4i, this is minus 3i, this is 1. Minus 4i square, it is I square is equal to 1. I square is equal to minus 1, therefore 4 into minus 1. Now minus 1 plus 9i, that is 1 minus 3i, this is plus. Minus 1 plus 9i, this is 4 plus 1, 5 minus 3i. This is. Now we have to multiply this and this, this and this. This is minus 1 into 3. Minus 3, minus 1 into minus 4i, plus 4i, plus 9i. into 3, 27i plus 9i into minus 4i, this is 36i square. Similarly, 5 into 5, 25, 5 into I, 5i, minus 3i into 5, minus 15i, minus 3i into I, minus 3i square. Now, write the value of I square and add this, that's minus 3, there is 31i, value of I square is minus 1, therefore minus 1 into minus 36 plus 36. It is also minus I square, this is plus 3, and it is minus 5i, 15i, minus 10i, 25 plus 3, that is 28, minus 10i, minus 3 plus 36 is plus 33 plus 31i. Now we have to rationalize this denominator. For this we have to multiply. We have to multiply conjugate of 28 plus 10i, that is 28 minus 10, that is 28 plus 10i. They are also 28 plus 10i. That is after 33 into 28, 924. 33 into 10, that is 330. 31 into 28, 868. 31 into 10, 310i square. That is 28 square minus 10 square, 10i square. That is 924. That is 924. After adding this 11988, this I square is equal to minus 1. Therefore, it is minus 310. 28 square. This is 10 square 100. Since there is I square, therefore this is also minus minus. This is plus 100. 314. That is 924 minus 310. 310. That is 614. 1198i. 784 plus 100 is. Now we have to rewrite it as this by this and this by this. 614 by 88, 1198, and after simplification we get 307 442 500, and this is a standard form as well as A plus IB form. These are all about the problem. Next class I shall come with many more problems. So for today I have finished my lecture.